talk about the lab two solution first. And a good place to start would be to look at the tests now that you can see them. And you notice that I had way more unit tests for my stuff than you had. So even for finding using index of, I had at least 3 tests where I was trying to see whether I could find something at the first, at the middle, and at the end. And one of the mistakes that people were making in their unit or in their code was that they forgot to make the fake worker and they plopped in the real one instead. And if you use the real one all the time, then your tests are going to succeed without having to write an equals in the worker class, because the default equals matches by address. But that's not the way equals is actually used. So you have to relax the restriction, have the equals in worker, and always make a fake one to try to find the real one. So that's why people were being caught in that test. And yes, I purposely left the equals out of worker so that you would discover that. Okay, so there were 3 tests for index of, and for inserting, I had a whole bunch of tests. So I played this basically the same sort of game with inserting. I tried to insert an empty list into an empty list, which should work, right? So that's the totally empty case. Insert an empty at the beginning. So take in that case, nothing, and try to put it at the beginning of the list, try to put nothing at the middle, try to put nothing at the end, try to insert one past the end, which is also allowed. So it basically went through every combination of insertions and variations of where you could put the thing to make sure it would work. So there's actually a lot of tests for insert. Okay. If we go look at the actual code, the code is got way less in it than the unit test did. And that's not a surprise. The general rule is every time you write an if statement in code, you're going to have at least 2 unit tests, because you have to test either side of the if statement. And if you have more conditions than that, then the number of unit tests just tends to explode. Okay. So index of was the relatively easy one. Go through all of the items and call equals to see whether or not you can find a match. Okay. The mistake that a lot of people made in this one was to try to overcomplicate it. And so, for instance, in the old days, what would have happened is there would have been an extra variable in here, because the rule was don't ever exit from within a loop. Okay? And so what people did was they wrote a condition variable to say found or not found, and then they made the loop run through, and if they found it, they broke out of the loop and exited at the bottom of the method. Okay? The reason for that rule, for writing those variables like that, those condition variables, was because people used to write very long pieces of code, and then they would proceed to exit from the middle of the code, and you would never be able to figure out how you were actually getting out, what condition was causing you to get out. So when people wrote very large pieces of code, the rule became always make yourself exit at the end, so we know there's exactly one exit point and we can work our way through the code to figure out what's going on. In modern coding, what tends to happen is we write very small methods, okay, with very small pieces of code. And if you introduce an extra variable into a small piece of code, it just clutters it up, okay? And so the modern technique has become to eliminate the variables, those extra condition variables, and just do exactly what you're supposed to do. So in this case, the code is so small that there's only 2 possible exit points. Either you found the thing at a particular position, or you go all the way through the loop and you don't find, and for that one we explicitly say, I didn't find it. Okay? Some people also wrote turned that into a named constant. Okay, so they made that a not found variable. The exception to the rule for naming numbers in code is you almost never rename the numbers 0, 1, and -1. Okay, so 0 always means 0, 1 always means just 1, and people are so familiar with -1 being an error, I couldn't find it within an array, that you rarely ever give that a name either. So those are the special cases for the naming rule. Okay, so that's index of. And then we get to insert all. And when you look at the code, the rule we have is ignore all the if statements and go right to the meat of the matter. So the only thing that in this code that does useful stuff is the 2 for loops. Okay? And you can look at it from a distance and go, should there be 2 for loops there? Well, let's see. The first one has to move all of the stuff from the end and shuffle it over to make room someplace in the middle. And the second loop has to copy all of the stuff from the external place into where it's supposed to fit within the array. So you immediately know, if you're sort of standing back from a distance, that there should be 2 loops to solve the problem. Okay? So if you see anything more than 2 loops, that's maybe a little bit of an issue. What does the first loop do? The problem that a lot of people had with the first loop is that they tried to get the loop control variable to do 2 different things. They tried to make it count the number of items, and they tried to make it keep track of the position, which means you end up with a backward counting loop. Okay? And the best way to deal with for loops is to forget the nonsense of trying to make 2 variables serve the same purpose and just always make the for loop count. And so we're back to a really, really simple rule for loops that says anytime you write a counted loop, you make it count from 0 to less than number of items, period. That's its entire job, its entire thinking for the loop control variable is I'm just going to count how many times I have to do something. And then you make a separate variable, in this case end position, that's in charge of worrying about, oh, okay, if somebody's counting things for me, where's the important position that I have to worry about? Well, the first important position is the one at the very end, because that's the one that's going to slide way over and help everybody else slide way over until you've made the room. Okay? So if you label that one as being, in this case, end position, the end position starts at the first full one and moves that thing over from where it is now, which is all items sub end position, into end position plus some offset. And so there's that idea that people are skipping forward not just one necessarily to make room, but if there's 3 items that have to go in there, we'll move that last box over 3 positions. Okay? There's other ways of writing this. I could have made a variable that kept track of that thing, but the whole idea of putting that phrase in there is that it makes it really obvious where people are going. Everybody's skipping plus this many forward. Okay? So there's no doubt about what's happening with that thing. So in this coding style, the idea of not putting comments in means that sometimes you have to write code that's very, very explicit about exactly what people are expecting. Might not be the most efficient, but you want it to be the most obvious. Okay? So we move the thing, skip it ahead, and then work our way backwards through the boxes, trying to push them all forward until we've made room. And then after we've made room, the job becomes going through all of them from the list that we were given and turning around and moving them from where they are now into the insert position plus where they are now. Okay, so there's another idea of using that insert position to indicate that that's where they're starting, but they're moving at an offset from that insert position within that array. Okay. The other thing I did here was originally this variable was just called position up top. And I've said to people the use of the word position was okay there because when you saw insert, then you saw insert and position and it all made sense. But by the time you get down to here, if you just use the word position, you've typically lost the sense of what position was I referring to. So I went back and renamed that variable so it appears a little redundant up here, but when you get down to the bottom, it's more obvious about how that variable is being used. Okay? And you end up with a fairly straightforward piece of code. Okay? So notice that this version is still flat. There's no ifs within ifs. There's no loops within loops. It's just a simple sequence of events that needs to be done. Okay? Now the next thing is I said, put in this idea that you're supposed to grow but don't test it. So this was code that was more or less borrowed from the add routine. Okay? And there's this idea that if there's not enough room in the current list to hold all of them, so there's not enough available positions in the current list at the end, we're going to need to grow. Okay? Now, some people said, well, that's fine, but that only works for just once. What if you grow a certain amount and you're still not big enough to hold the number of items, right? You grow by 10, but somebody's asking you to insert 100 items, there's still not going to be enough room. What do you do in the case where there's still not enough room? Some people tried to worry about that by going inside of the if statement and writing something else to try to do the work. But here's the simple trick. Whenever you have a loop like this that works for one time, if you want it to work for more than one time, you change the word if to while, which says, instead of worrying about once, let's keep going until we've made sure that it's grown enough to do the work. Okay? And so there's that idea of while being uncertainty. I'm going to keep doing this for as long as I have to. I'm not sure how many times I'm going to have to expand, but I know that sooner or later, if I keep doing this, I'll be large enough to hold the result. Okay? So if I change that if statement to a while, did I just create an infinite loop? If that's a while loop, what's going to make the while loop stop? Yeah, the only two things that are going to make the loop stop is, or the only way that the loop is going to stop is if one of those variables inside what's now an if statement changes to the point where one's bigger than the other. So either one or both of those variables somehow have to change in order for the loop to stop, in the case of growing more than once. So is the loop going to stop? Is either one of those variables going to change?
Available position, but if it's low available position.
Well, other list.size is fixed, so it's never going to change. Available positions is a constant because it's done once, it's calculated once and never again. And so this loop has a potential to never stop. So the way that you fix that is you either put this calculation in after you grow to recalculate how many available positions you have, or you just do the other thing, which is you take the calculation, and you dump it in here so that now it recalculates, because all items dot length is the thing that will change as you grow. Okay? So that idea of replacing an if statement with a while works really well as long as you're really cautious about making sure that the variables will actually change to force the change to force the loop to eventually end. Okay? But that's a slimy little useful trick for if statements versus while statements. Okay? Any questions about the code? Seems so straightforward now. Okay, in that case, let's go talk about beer. Beer is so much more fun.
Yeah, do you have any? Can we have?
Here's our diagram of a forest. I've labeled the clearings with numbers. And I've made places where you can go from one clearing to another. So in this case, from clearing number 0, I can get to 1, 2, and 3. Okay? If I just write that out, from clearing number 0, I can get to 1, 2, and 3. From clearing number 1, I can get to 4. Clearing 2 gets me to 5. 3 goes to 6. 4 goes to 7 and 8. 5 goes to 9 and 10. 6 goes to nothing. 7 goes to nothing. 8, 9, and 10 all go to nothing. There's a table. Okay? So part of the trick to this game of solving the problem is to take that diagram and turn it into some sort of table, because we can write code that processes the information in the table without really having to worry about the special case if then else's. Okay? And so what I've done with the code in the main program is I've made that idea that we're going to do a table of things, and there's that same notation. From clearing number 0, you can get to clearing numbers 1, 2, and 3. From 1, you can get to 4. And we can just basically extend this table for all of the other cases. Just let me copy that, paste it in a whole bunch of times. So we've got clearing 2, 3, 4, 5, 6, 7, 8, 9, 10 should do it. And let's just put in some commas at the end of these lines. Make the syntax errors go away. The last one, by the way, doesn't necessarily need a comma, but if you're planning on expanding the table, it won't hurt to put that comma in there. So from clearing 2, we can get to 5. Clearing 3 goes to 6. 4 goes to 7 and 8. 5 goes to 9 and 10. And then the rest of the items don't have anything in them. So notice, by the way, that for these empty items, you'll actually get an array with 0 size. It makes an array, but it doesn't give any valid positions for it, but that's going to be useful to us. The other thing that's useful in this table is notice that clearing identifier number 0 happens to occupy the 0 position in the table. And that's handy because if we're looking at clearing 5 and somebody says we're going to clearing number 9, you can just whip down into the table index position number 9 and you've got all the information about position number 9. Okay? So it's those numbers, the fact that they correspond to table positions is actually useful. Okay? The clearing class itself has got the identifier, whether or not you've got beer, and it's got that integer array of clearing numbers. Okay, and we just remember all of those clearing numbers. We copied them directly because essentially they're not going to change for the life of the program, so there's no use in making a different copy. We might as well just point our variable to the copy that's already there. Okay, so there's our clearing class and our driver, and now we're all set to play the game. So let's just do the simple version of the game where we don't keep track of the path just run through it once so that we've got set in our minds what's gonna happen with this thing. So here's our game. What's the first thing that you do? Very first thing. So go back to, it's Friday night. We're gonna start to play this game. What's missing from the diagram? Beer. So someplace along the line, somebody's gonna have to go set one of the clearings to say it's got beer in it. After that, what's the next thing you do? How are you gonna know which clearing to go to?
Pick who's gonna go look for it.
You've gotta put something on the to-do list to start the game rolling. So the first two steps are put beer in the clearing and then go tell somebody you need to start at this place to go start checking for beer. Okay, so now somebody comes along and says, oh, okay, let me go hunt for the beer. What do? Go grab the first thing off the to-do list. Okay, I need to look at clearing number 0. Any beer at clearing 0? What's the next step?
Fill the list with possible.
Fill the to-do list with all of the stuff that you haven't got to yet. So I haven't got to clearings 1, 2, and 3. Take a breath for a moment. After all that running, turn around and go, oh, I should do something else. What have I got to do? Let me just take the top thing off my to-do list. Check clearing number 3. That's the place I'm supposed to go to. Any beer there? No. What do I do?
6.
Put 6 on the list. Add 6 to it.
Add 6 to the to-do list. That's someplace I can get to from where I am. Stop and take a breath. Wait for a minute. Oh, I got nothing to do. What should I do?
6 back there.
Go back to the to-do list now. Look at clearing number 6. I need to go to clearing number 6. No beer there. Anything that I can add to my to-do list? Nothing. Oh, okay, nothing to add to my to-do list. Stop and take a break. What have I got to do now? Oh, I should go check clearing number 2. I guess that means on my map I have to go back to there and then forward to clearing 2 to check clearing 2. No beer there. Okay, we'll put 5 on the list. Stop for a moment. My to-do list says check clearing number 5. No beer there. I'll put 9 and 10 on the list. Let's check clearing 10. No beer there. I guess we don't have to worry about clearing 10. What do I have to check next? Clearing number 9. Go check clearing number 9. There's the beer. Okay. So now that we know the process, let's see if we can write that in the code that we've got. So there's the starting point for the code. What's the first thing that you want to do?
What were the beers?
Set the beer someplace. So all clearings sub 9 dot set has beer to true. Somebody placed the beer. Now what?
Starting point? What's the one to do?
Next step.
Put 0 on the list?
Put the first item onto the to-do list. Okay, so we don't have a to-do list.
Bill, that's what you do.
Definition for a to-do list is it's gonna be a stack, and the stack is gonna hold what kind of things? Stack is gonna hold clearings, and this is going to be our to-do list. So there's our to-do list. Got our to-do list. Need to place the first element on it. To-do dot push all clearings sub-0. Now, be a little bit careful here. On my to-do list, when I put a 0 in there, I'm using an integer number. But in fact, what we're doing in our Java code is we're not pushing numbers onto the stack. We're actually pushing references to the particular item in the table. Okay? But it's just easier to represent this thing with numbers in this case. Okay? Now what? Pardon me? We could, but in general, what's going to happen at this point? Over and over and over again.
Check for beer and then check for any bats.
We're uncertain as if we will ever find any beer when we go hunting for it. So uncertainty over and over again means it looks like we're going to have to keep trying until we find the thing that we're looking for. Don't know when it's going to happen. What's a reason why we would stop? That's one reason. Is there another reason why you would stop?
The stack's empty?
If the stack is empty. So in other words, even from the very start, if the stack was empty and your friends were pulling a trick on you saying, oh, we're going to go out and hunt for beer, but there was nothing on your to-do list, you would just stop. Okay? So the easiest empty condition is that there's nothing on the to-do list to do. So let's just make this while to-do dot size has something in it. Okay? So now if you put something in there, you know you're going to do it at least once. What would you do just one time? What did we do for the case of one time? Standing at the to-do list,
Check the beer?
go grab the first thing off the to-do list. So that's clearing top item is to-do dot pop. Got to be at least one item. Now what? What did we do for that item? Checks to see if there's any beer. So if top item dot has beer is true, then we would take some action. But we don't have has beer written yet, so we'll go into the clearing class and we'll write public boolean has beer to return the value of has beer. Should be get has beer, but close enough. So, if you find the beer, what would you do?
Report the fact.
Well, don't have the reporting in yet, but at the very least, what would you say? Found it. So let's do system out print line found beer at top item dot get identifier. And so we should go into the clearing class and just do the getter for the identifier. Probably missing a semicolon at the end. Okay, so we reported that we found the beer, and then what? We're done hunting, so at the point where we're done hunting, the thing that will stop us is break. So break will kill the loop. No need to look any further. If this were inside a method, this would be a return statement to get us immediately out. But in this case, since there's no method, break gets us out of the while loop. Okay. So we reported that we found the beer, and we'd basically be done. Okay. What if we didn't find the beer? Let's just print out a done here so we can see it. So there's the case inside the while loop of found the beer. That's one case. The other case is, what if we didn't find the beer? What would we do? What did we do in the case of didn't find the beer at 0? So it was push all the other paths that we can get to onto the to-do list. Done. Huh? It is inside the while loop. Sure, because that's what we do. If you don't find the beer, your immediate reaction is, okay, let me go and push all the other things I can get to onto the to-do list.
We do need to do something
Okay.
to
So,
get an actual.
Notice the part of the deal here is that rather than worrying about the details, I took exactly the phrase that somebody said of what our intentions were and said, let's just do that thing. There's the self-documenting thing. And then we'll go later and we'll figure out the details of how to do that. Because it just seemed too complicated at the time, but the words were really obvious when somebody said them. So now we can go and we can write this method and figure out what the details are supposed to be. To actually do all the work. So that's a good programming skill. Don't get involved in the details. Say what you intend to do, get it in your brain what you're trying to accomplish, and worry about how you do that later on. What information do we need in order to put all the paths onto the to-do list? We need the current clearing. Anything else? We need the stack or the to-do list, because we said that's where we were going to put the result. And anything else? Well, we'll give that a try. Okay, so let's see. There's the definition of what top item was. And the definition of the to-do list was that thing. So I'm going to sneak that into here. Is there some reason why I don't just use the clearing object and the stack directly. Like, in this case, our two options were I could either pass the things as parameters, or I could move the stack and the clearing into the top of the main program so that they could be seen by everything in the main program. What's the difference? Which one's better? Move the variables up where they can be seen, or pass them as parameters?
You've got more control over what methods do to them if they're created in main, whereas any method you make could mess with any aspect of it. It's more compartmentalized.
So the first thing is that it's more compartmentalized, right? If you're being explicit about what you need here, right? Okay, so there's no doubt you're saying I'm only going to use this stuff in order to accomplish my job, which is way better than saying, oh, you have free license to use whatever things you want. The second reason for doing that, by the way, is that you can eventually always unit test a method. Okay? You can't unit test stuff that has no parameters on it. So if you can get all of your stuff into a method, then you've got the ability to write some tests for it. Okay? So it's always a good idea. And there's the trick. All that you do to get the method is you just repeat the information that you need, just borrow the definitions, use exactly the same variable names, you don't have to change them at all, and you can turn the thing into a method. Let's just see what it's upset about here. Oh, this thing has to say static on the front of it because it's just a main program. Okay, so now we can worry about how do we push all of the paths. Okay, so in this case, we've got to figure out how to go talk to clearing number 0 and get the items 1, 2, and 3 out of it. Okay, so the thing that we're going to talk to is the top item that we're dealing with. Maybe that name is better as current. Don't know, but we'll call it top item for the moment. So you're going to talk to the top item. How are you going to go and retrieve the clearing numbers? Got a couple of choices here. We're hiding this array of clearing numbers inside the clearing object. So how's somebody from the outside world that's not a clearing going to talk to this thing to go get them? Call a method that asks for them. How do you want to ask for them? What's the obvious choice here?
Just get the whole array.
Option number 1 is give me back the whole array so I can deal with it myself. Sort of exposes the whole array to abuse or somebody being able to do things that you wouldn't want to do to it, because that's giving them essentially read and write access to the array. Anything that's a little more restrictive?
Array sub-clearing item?
Make them ask for one clearing at a time. So go get me the position of the 0, 1, 2, 3, or the items that you've got, right? Okay. If you say go get things by position, what's the other method that you need to write? Anytime you say I want things by position. I want the 0 item, I want the 1 item, I want the number 2 item. What's the problem there?
Track the size of the...
Whoever's asking needs to know when they're done. So they always need to know what's the maximum number I have to ask for so that they don't run off the end of the array. So first option is that we could make this thing return, you know, like public clearing get position, right? And if you wrote that one, in addition, you would also have to write public int size, because those two go together. So that's option number one. Sorry, option number two. Any other options?
Couldn't you make it so that if the, position that's passed in is larger than the size, it just returns a -1?
You could, but that's forcing an error if you always have to check for the -1. So it's easier to know up front, this is how many I have to go through. What's the thing that we have, the concept that allows us to look at stuff without disturbing it? Iterators. They allow you to go through all of the things with a lovely and talented and easy for each and not have to worry about position or maximum number of items. Just go get me all of the things that you have. Okay? So rather than using these two, it would be a little bit more sophisticated and easier if we could somehow manage to use an iterator. Okay? What's the thing that we want to iterate through? That thing. Okay? Now, it turns out that you can also do for each out of arrays. They backfilled it to make sure that would happen when they made for eaches. So we can say up here, implements iterable for clearings. And then as soon as we say that, we're forced to write the iterator method. There's our iterator method, and we can return, if we're lucky, all clearings dot, oops, if I spelled it right. Come on. Sorry, it's not all clearings, it's clearing numbers.
Two U's in that number.
Doesn't quite work. You would think it would work, but what's wrong?
That's an array integer, it's not an array list.
It's the thing that we're storing is an array of numbers, it's not an array of clearings.
Can you make it a capital I integer?
So what we can do here is we can say, oh, the thing that we're going to give you back is not clearings but numbers, and this is where you can use the capital I integer object, and we can change this thing to say what you're going to get back is numbers out of this thing. Oops. Let's just see if it'll do this for me. I don't think so. I'm looking for my I'm just looking through the array options to see where I can find my my iterator for arrays, and it's not going to give it to me. Oops. Not going to work. Because much as I thought that it gave iterators, there's nothing in the array list of things that actually gives an iterator. We could use array list, but the numbers aren't actually in an array list right now.
Have you tried length?
You wanna play that trick?
Yeah, have you tried
We've got an array here that we don't have an iterator for. I know that array list has an iterator. So if I could get all of the integers from an array into an array list, I would then have an array list that I could turn around and return array list iterator. Got that nonsense? So for instance, if I go back here and let's just make an array list in here. So this is a list of integers. We could call new array list at this point to get a new array list. And then here we could now return all clearing numbers dot iterator. Brace in the wrong place. Okay, and that would mean I could write a for each in clearing numbers all clearing numbers dot add oh, that'll work. Now this seems like I'm going to a lot of trouble, but what happens in the driver program, if I can send back an iterator, it makes life really easy for the driver program because the driver program just sees a for each. And so as a general rule, you do lots of work in the lower classes to make it easier for the upper classes to deal with things. Okay? So all this code does is it says, well, gee, I can't get an iterator out of an array for some reason, but I can get an iterator out of an array list. So I'll copy all of my numbers out of my array into an array list, and I'll send back the array list iterator, and then the calling program just sees a for each. Okay? It turns out that this idea of copying all of these out of there happens fairly frequently, and there's a shortcut for doing this loop, which is you can go to the array list and you can, in the constructor, say I want to mention the array, except if you try to mention the array, it gives you an error that says, hold it, you can't turn an array into an array list. But if I say arrays.asList of this thing, that's just a convenience method. Hopefully. Let's see what it's complaining about now. Make this a if I get lucky, I might be able to do that. I guess it's not going to like that. Just taking a quick look at this. I thought it would let me do that, but my little convenience method is upset because I probably have to specify. Let's just be explicit on that thing and see if it's happier than. Nope. It will. Okay, there is a convenience method, but apparently I don't know how to use it. So we'll just go back to the longer version, which is that for now.
So why didn't we just make the list originally as an array list?
You can, and we can go back and find a way to do that, and maybe we will tomorrow. Okay? So we're going back and forth here. Originally what happened is we had this as an array list, and we decided it was more convenient to use it directly as the numbers. But if the point is, gee, if we're going to all this trouble to convert from an array back to an array list, why don't we just turn around and make this an array list to begin with? So we'll try that tomorrow and see whether or not we can simplify the code to just have it always use a list, which would be sort of nice. But for now, we've at least got to the point where we can run a for each. Okay, so tomorrow we'll finish off this little loop in here to go through all of the items and push them on, which is now just a simple for each, and then we'll worry about doctoring the clearing class to maybe make it a little easier to use.